Good to have you back. Conditional probability. That's the lesson for today. So let's go ahead and start with the formal definition. The conditional probability, this notation P, open a bracket A and then bar B, close a bracket. I'm going to explain what that is and how you read that. I wrote it down here actually. Is the probability that event A happens knowing event B has happened, and that's what is called conditional probability. Now the notation says probability of A given B is actually this, which is equal to probability of A given B has happened. Okay, this is straight up and down bar. That's the given part. And basically these questions, they're done three different ways, and all three of them, they're easily acceptable and easily understood. Whichever you actually resonate with, just you can do that. That's not a big deal at all. So let's go through what it is with the formal definition first. In the formal definition, that probability of A given B is given by probability of A intersection B divided by probability of the event B. And the other way of writing it is probability of A and B divided by probability of event B. Now, be careful with this part, because remember, depending on if you have a dependent or independent event, this probability statement, which is on top, probability of A and B, can be different. One could be a multiplication, or if it is a independent. If it is dependent, then you just have to be careful with that and include that in there. Okay, so be aware of that. So let's go ahead and now look at what we have with an example. So we have a couple, they have two children. What is the probability that two children are boys? So that's very straightforward. Let's look at the sample space first. The sample space, what are the options we have? We have boy, boy, we have boy, girl, we have girl could be first and boy second, and then we have girl and girl. Okay, so this is what we have, and the total number for the set, we have 4. Okay, and now we can easily look at it. What is the event that we want the two children's being boy? So here we go. If we have, let's call this event A, we have boy and boy, and that means the probability of that is happening is 1. That means 1 out of 4. Okay, and therefore we can easily say that 1 out of 4, which is a quarter, 0.25 is the probability of having 2 boys. Okay, so that's the first part. The second part to this question is, what is the probability that the two children are boys given at least one is a boy? Okay, now this is the conditional probability that we have talked about up here. So let's go ahead and let's go through all three different methods. The first one, let's do by reasoning. Method 1, the first one, we're going to talk about this by reasoning, just normal reasoning. So what do we have? We have sample space that we have now for the second. So we have boy, girl, girl, boy, and we have boy, boy. So in here, n of s is equal to 3. And in this case, we know that there's only 1 in here that is boy, boy. That means n of a is 1. So simply we can just say that probability of 2 boys given the first is a boy is equal to 1 out of 3. Very simple. Okay, so the reason the sample space for the second part is only 3, not 4, is because we have remove the girl because the first one already has to be a boy, so the girl completely gets eliminated. It doesn't even apply. So we only have three elements in the sample space. And of course, what we want is 1 out of 3, and that's what that is. You can read it off right there. Now, let's do the method 2 and using the definition, and that may be a little bit more complicated, but I think it's a good exercise. So here what we have, let's A be the two boys, the event having two boys. So the probability of A is probability of a boy, boy 1, and then times the probability of getting a second boy second round. And of course in here we know that is 1/2 times 1/2, which is equal to 1/4. Okay. Now let's, if B, the event B is at least one boy, and if what we have here then will be probability of the at least one boy will be probability of, that is 1 minus probability of two girls. Okay, so once we do that, then we are set up very easily. And in this case, we know that would be 1 minus 1/2 squared, because two girls is the same as two boys, so it would be 1/4. The answer will be here 3/4. And once we have this, the probability of having two boys taking away the two girls already, then we can write up the conditional probability. Probability of A given B is equal to, and then we already know that because A is a subset of B, probability of A and B divided by probability of B, given the fact that A, remember, A is a subset of B. So what does that mean? That means that A intersection B is actually A. Okay, that's what it means. All right, so if we have that, then we can rewrite it as, so this would be probability of A divided by probability of B. And this just easily 1/4. We already calculated on top, divided by 3/4, and the answer will be 1/3. Okay, so that's another method. And it's so important to check that out, because for the method 2, when we are dealing with the probability of the two boys, the first one would be half, the second one would be half, so 1/4. And then when you set it up, by the way, this is another way of doing this. You can use another way, at least one boy. You can actually write up the whole thing, but I just decided that they could use the complementary part of the probability, just use the 1 minus whatever is left over. So that would be this statement right here. So 1 minus 2 girls will give me the probability of having at least one boy, which is 3/4. Once we have that, then we just go ahead and do the probability of A given B. That's probability of A and B divided by probability of B, and that is the formal definition, which is our given, was given to us up here. That's the probability of A intersection B. But in this case, the A was a subset of B, so probability of A and B is actually A. All right, and that's the quarter on top, which is right up here, right? And then you divide it by probability of B, which we calculated here, which is 3/4, and that's what we got. We got 1/3, which is the same answer as the first method. And the last method, method 3, is the tree diagram. Okay, the tree diagram is actually very straightforward. I just have to read it off properly. Let me set it up first. So what do we have here? We have girl and a boy. Probability of each one happening is half at first. Then the second is going to branch off again in each case. Okay, and in this case again we have 1/2, 1/2. We have boy, girl to a small one, boy. So boy, girl, girl, and boy. And then we have 1/2. We also have 1/2, and they're all 1/2. Now let's go through the branches. So if we start using this branch on top, okay, so we have the first one we have is the boy and boy. So that's this one right here and this one right there. Okay, so that gives us 1/2 times 1/2, that's 1/4. Okay, that's our first branch. Okay, now what else do we have? We have the total, the sum of all three other blind branches. Well, each one of these ones will be at least one of them. So this one will not work. This is impossible. So this one we ignore completely because girl already is not even one of them is a boy. So the next one will be this one, which is 1/2 times 1/2. So that would be 1/4. And then so as this one, now we're going to take care of this one, which is boy and girl, which is 1/2 again times 1/2, which is equal to 1/4. Okay, now we have, so now we're going to set it up, and that's basically you take the first branch boy and boy, that because one of them was given to us, right? So here it is, the probability of given at least one boy, and that would be equal to, so we have 1/4, which is the first branch right here, divided by 3/4. Okay, so the total in here, that's 3/4. All right, and then when you do the math, that's simple, and that we get 1/3. Okay, and that is the third method using the tree diagram. And that's basically it. Whichever method you are comfortable with and makes sense to you, you can use that. I have students, they use the first method very easily, and I have other students that they use the tree diagram method. Some students, most students, they got confused by the middle, the method 2, but I think that's a straightforward 2. It's a little bit more involved, but still, that's not a bad method as well. You decide which one. All right, make sure you go through the quiz as well. Check out the next video in the series. Until next time.